Is my computer organization and architecture tech talk presentation, and my tech talk presentation topic is arithmetic logic unit, we called as a ALU. So see this diagram. I draw this diagram for understanding how it will be work. So first of all, we are giving the input to accumulator, and it going to arithmetic logic unit, and it going to control unit, and it store the memory, and again it store in the control unit, and it store in the arithmetic logic unit accumulator, and it gives the output. Okay, so the next one is mathematician John von Neumann proposed the ALU concepts in 1945 when he wrote a report on the foundations for a new computer called as the EDVSC. So he is the person of John von Neumann, mathematician. Okay, so he's from USA. And guys, what is an ALU? The ALU is a fundamental building block of the central processing unit of a computer, and even the simplest microprocessors contain one for purposes such as maintaining timers, and the processes found the inside modern CPUs and graphic processing unit like as GPUs accommodate very powerful and very complex ALUs. Okay, one is nothing but ALU complexity. An ALU must process number of using the same format as the rest of the digit circuits. The format of the modern processors is almost always the 2's complement binary number representation. Early computers used a wide variety of number systems, and including 1's complement, 2's complement, and sign magnitude format, and even true decimal system, which various representations of digits. So the next one is the most of processors operations are performed by one or more ALUs. An ALU loads data from input registers. Then an external control unit tells the ALU what operation to perform on that data. Then the ALU stores it results into output register. The controller unit is responsible for moving the processor data between those registers, ALU and memory. Complex operations, engineers can design a arithmetic logic unit to calculate most operations. The more complex the operations, the more expensive the ALUs is, the more space it uses in the processor, and the more powerful it dissipates. Therefore, engineers comprise they make the ALU powerful enough to make the processor fast, yet not so complex as to become prohibitive. For example, computing the square root of a number might use. So guys, see these points. Number one is calculation in single clock. Design an extraordinarily complex ALU that calculates the square root of any number in a single step. So second one is calculation of pipeline. Design is very complex ALU that calculates the square root of any number is several steps. The intermediate results go to through a series of circuits arranged like a factory production line. The ALU can accept new numbers to calculate even before having finished to the previous ones. The ALU can now produce number as fast as single clock ALU. All through the results start to flow out of the ALU only after an initial delay. Iterative calculation, design a complex ALU that calculates the square root of through several steps. This is usually relies on controls from a complex control unit with built-in microcode. Co-processor, fourth point, co-processors design a simple ALU in the processor and sell a separate specialized and costly processor that the customer can install just beside this one and implements one of the option above. So next, sixth point is software libraries. tells the programmers that there is no co-processors and there is no emulation, so they will have to write their own algorithm to calculate square root of by software. 7 point is software emulation. Okay, what is software emulation? Emulate the existence of the coprocessor. Whenever a program attempts to perform the square root of calculations, make the processor check if there is a coprocessor present and use it, therefore is 1. If there is not an, interpret the processing of the program and invoke the operation system to perform the square root of calculation through same software and algorithm. So final input and outputs. The inputs to the ALU are the data to be operated on, and a code from the control unit indicating which operation to perform. It outputs is the results of the computation. One thing designers must keep in mind in whether the ALU will operate on big Indian or little Indian numbers. For example, refer the convention used to interrupt the bytes making up data odd when those bytes stored in computer memory. And last one is, in many designs the ALU also take or generates inputs or outputs a set of condition codes from or a to status register. These codes are used to indicate cases such as carry in or carry out, overflow, divided by 0, etc. I hope you guys everyone can like this video. Thank you for watching.